Hello everyone! In this video, I'm going to show you how to use LaTeX and how to use Overleaf. So first, let me explain a little bit about what LaTeX and Overleaf are and why we're going to be using them. So Overleaf, as you can see, I have the website up here, is a collaborative online platform for editing LaTeX. LaTeX is a programming language. It's spelled like latex, but technically the X character is supposed to be the Greek letter chi, so it's pronounced like a K. So it's LaTeX. So LaTeX is a programming language that is used by all mathematicians and computer scientists to typeset their mathematical notation, their mathematical documents, textbooks, reports, everything like that. So the odds are you've read and seen a lot of LaTeX documents in your life without realizing that that is what they were, as most textbooks are written in LaTeX. So it's a markup language where that means that you mostly write text, but then you have some programming and syntax thrown in there to tell how the document should be formatted. Okay, so it was invented in the 70s in order to be able to do home typesetting, as the sort of the use of professional typesetting was falling by the wayside, and typewriters were not really good enough for the job. So it was invented by Donald Knuth. If you're a computer science major, you should certainly know who Knuth is. Probably the most famous computer scientist of the latter half of the 20th century. Anyway, so this is a skill that will definitely be useful if you ever need to write a technical paper or technical report in a math or computer science job. Definitely, if you go to graduate school, you'd be expected to know this as well, and it looks good on a resume, so that's something you can add to your resume under your software or your programming languages section. LaTeX. Okay, so LaTeX is great, and Overleaf is a website where you can do LaTeX, you can write LaTeX, and you can also collaborate with other people to write LaTeX together. So just like any other programming language, you can also install a compiler for LaTeX on your computer and an IDE, a programming environment, and do everything on your own computer, but it is so much trouble. It's just as much trouble as doing it for any other language and more difficult than for some languages. Like, I think it's easier to install Python than LaTeX. So it's just much easier to do it on Overleaf. And Overleaf has a great interactive developer environment anyway, compared to the other IDEs that are out there. So we are going to use Overleaf. So we're looking at the website right here, and all you need to do is just register for a free account. You can fill in the blanks here. You can use your Google account if you want. It's up to you. So once you've registered and you've logged in, it is going to take you to your projects page. So let me show you my projects page. Here's mine. So I have a ton of projects in here because I really do use Overleaf for my own scholarly work. I write my papers that I submit to journals in Overleaf. So when you're first starting out, you're not going to have any projects. So there's a few ways you can get a new project going. If you click on New Project over here, you can start a blank project. There's some example projects. You can also look at these templates here for different things. And the very particular thing that we're going to be doing in this class is the upload project. So I'm going to be providing zip files on Blackboard for you to download and then upload as projects on Overleaf. Okay, so I'm going to go ahead and show you how to do that. I'm going to upload a project, select a zip file. I'm just going to go to my downloads folder where I downloaded it. And here is the zip file that has an Overleaf project in it. And it's just going to go ahead and open it for me. So you're going to be working on Overleaf projects with a partner for the most part. So let me go ahead and show you how to share a project with a partner and how to work on it together. Let me move my face over here. So up in the upper right-hand corner is this button called Share. So when you click on there, you can put in the person's email address that they use to sign up for their Overleaf account with, and then make sure that you have the edit thing selected there if it's going to be your partner. Another way you can do it is with the link sharing. So if you click turn on link sharing, then you can send people the link to be able to edit the project, as well as to be able to view the project. Okay. So anyway, that is how you share documents. And then when you're up in your project folder, when you first log on, you can see who the owner of a document is, and that will be the person that basically started the document. Now, if you are working with a partner and you guys start out together, but then you can't find another time to like finish up at, and you decide to finish separately, you're going to want to each make a copy of that shared document and then work on your own copy that's not shared. Okay, unless you decide to finish it separately, but still like collaborate on it. Basically, you could collaborate like by email or whatever. That's fine. So if you want to make a copy of something, there's a little copy button right here, and you can make a new copy of your project and then just don't share that one. So a couple of last things to mention about sharing is you'll be able to see who you've shared your document with. It'll be like up here in the right-hand corner. And you can also see who is currently looking at it. And if more than one person is currently looking at the source code or editing it, you will be able to see those changes live as they're happening with only like maybe like a 1 or 2 second delay. So when you guys are working on a project together, you don't necessarily have to do a share screen to look at the document together. You can just both work on the Overleaf website, and as long as your internet connection is pretty good, that is a perfectly fine way to look at the document together. What I want to talk about now is what we're seeing on the screen when you have a project open. So there's 3 panels here, which is pretty similar to how a lot of programming environments look like. So over here on the left panel is where all of your files and things would be if you had any extra files. And then in the middle here is your source code. So this file over here, main.tex or main.tech, that is this source code file right here. Okay, that's the big middle panel. And then over here on the right, this is your PDF. So this is what you're going to show to other people when you're done writing your document. This is what would be printed in an actual, sheet of paper from your printer. So I'm not sure how much programming you guys have done. If you've only done something like Python that's not a compiled language, then you might not be familiar with the concept of compiling. But basically, we're going to issue commands over here in LaTeX, and then we have to compile, which means like we send them to the computer to be interpreted basically, and then the computer replies with the PDF stuff over here. Okay, so every time you make changes over here in this middle panel, like if I type hello or something, it doesn't show up over here on the right in the PDF until I do the recompile button right here. You can also press Ctrl S, the keyboard shortcut is Ctrl S or Command S if you're on a Mac, to recompile, and then you will see your changes over here in your actual document. So you can see now it says hello. So a few other things about navigating around in your project and the different tools that you have. I'm actually going to open a different document that's a lot longer because I think these things will make more sense with a longer document. So, okay, so this is an actual paper here that I submitted to a journal and was published last year. So as you can see, I have some actual files over here, different files, and when I click on them, they, something different comes up there in the middle. Okay, so here's my main tech file with my source code, and it's very long, as you can see. So one thing that will happen is that you'll be looking at your source code and then you'll try to find it in your PDF, but there's actually a much faster way to do this. So when you're over here on your source code and you want to see, for example, what does this equation look like on the PDF, you can just click this little arrow right here that says go to code location in PDF, and it will jump you right to the part that's near where you highlighted at. And then if you want to go in reverse, if I want to see, for example, what was the code for this section title right here, I can click the other arrow, go to PDF location and code, and it will take me right to somewhere at least near that part. It's not always right on the spot. So that is quite useful. Another thing you can do is you can download your PDF. So you can click on download PDF right there, and it will just download the PDF version of your paper, and then you can, open it in Acrobat or whatever you like to read PDFs in. Some other useful features that you have in Overleaf are, for example, the spell check. So here you can see I have the little red underline on this word pseudocode. So if I right click on that, it's going to give me some suggestions, or I can add it to the dictionary. Some other nice features that exist in Overleaf are, for example, autocomplete. So if I start typing a command like backslash, I don't know, frac, and then I can scroll through this list with the up and down arrow keys. And when I find the thing that I want, I can either hit enter or tab, and it will be inserted automatically like this. Okay, and then it automatically puts me into those little curly braces there, and I can type whatever I want and then use tab to go to the next one and put whatever I want in there. I don't know what that actually looks like, so I'm gonna delete it. Okay, and then the last thing that is really useful about Overleaf is it will help you find your errors. If your errors in your code are bad enough, your document may not compile. Sometimes you just get warnings, but other times you get outright errors and it won't compile. So like, for example, if I type an equation with a mismatched number of curly braces like this, it is not, I don't know if it'll compile. Sometimes it'll compile even when even when you did something pretty bad. Yeah, so it's still compiled, but you notice over here I'm getting this little red X. So that's going to show up wherever you have an error at, and it will tell you what the error was if you hover over that. All right, so that is most of the useful things that you can do with the Overleaf editor itself. Maybe the only thing I didn't mention is just kind of resizing these panels. Like, you can move those around. You can completely hide the left panel if you want to. You can also zoom in and out on the PDF, which is typically useful if you have big margins. All right, so that's it for Overleaf and how to use its controls. So now I want to actually teach you how to use LaTeX, which is the thing that we're going to be writing over here in this panel. So let me go to my other document that I had up. Okay, so we're going to go through this line by line, and I'm going to show you how to do all of the things that would be necessary in your assignments that you're going to have this semester. And I'm also going to explain how the code itself works, what all the different lines are doing. Okay, so first line right here we have is document class article. Okay, so this is telling LaTeX that the particular type of document that we want to write is an article. Usually an article is the kind of like the default class. You can think of an article as like, you know, like a magazine article. There are other ones, like for example, there's book. So if you put book and compile it again, I just hit Ctrl S to compile it. It's going to do a title page for the title instead of having it just right in front of right at the top. And then it's going to start on the next page. And it starts numbering the sections from 0 also, interestingly. So article is the one that we'll usually use. There are lots of them that exist, and you can even write your own classes that have some special formatting that you happen to like. For example, I can show you AMS Art. American Mathematical Society is the AMS. Looks like that. It's a different font. I think ACM Art is another one I've used before for Association of Computing Machinery. Is that right? Yeah, it has a different font as well, and things are aligned differently. So these different classes exist, but we'll just go with the default article one. Okay, the next thing after that is your packages. So packages in LaTeX work pretty much the same way they work in the rest of the computer programming world. A package is a big file that has a bunch of different commands and shortcuts and functions and things, extra functionality loaded into it that you need to load if you want to use those things. So there are always going to be 4 packages that we always use, and the default one that Overleaf puts in, the input ENC, is not one of them. We actually don't need that one. So the 4 packages that you're always going to use are the following. They are all from the AMS, the American Mathematical Society, and they're called AMS fonts, AMS symbol, symb, AMS, theorem, THM, and AMS math. Okay, so we're always going to use those 4, and those will be in the templates that I put up on Blackboard for you, so you don't have to worry about this part yourself. Okay, and then after you've loaded your packages, you can also define any sort of like, kind of similar in programming when you define functions, you can define like specific special commands that just belong to you that you want to use. And there's actually going to be one that we always do. And I don't know why this one isn't built into LaTeX itself, but it just isn't. So we're always going to have the new theorem command up here. So we do new theorem, lowercase theorem, uppercase theorem, and then section. Wait, I got these in the wrong order. Oh my gosh. I have to be really careful with the syntax here. Again, this will always be loaded into the templates that I give you by default. But what this does is it defines an environment for us to write theorems in. And I will tell you what that means when we get to it. For now, don't pay too much attention. Okay, so the next stuff is the metadata. This is the stuff right here that's going to go over here in your title, your author, and your date area. So title, LaTeX Demo Live is fine. Author, I'm going to change that to myself. And you can have multiple authors in here as well. You probably will for your overleaf assignments. Do / and then put the other person. I'll just put my cat, spot the cat. And then now when I recompile with the Ctrl S or Command S, you can see our names are listed there as the authors. Now the date, you can put whatever you want there. I usually delete it because if you delete it, then it will automatically put today's date that you compiled it on. So that's convenient. Okay, and all of this stuff that I just went over, lines 1 through 6, that is called the preamble because it's stuff that is not actually in your PDF. I know you're thinking, but this stuff was in the PDF. Actually, that stuff's not in the PDF. The part that makes this title over here, all this stuff up here, the date, the title, the authors, is actually this line 10, make title. So if I take that out, let me show you, then there's no title or author or date there. Okay, so oops. So keyboard shortcut for undo is Ctrl Z. Very important one to learn. Ctrl Z, undo. You must learn Ctrl Z or Command Z. Okay, so after we finish the preamble up here, then we begin the actual document. So you're going to have a begin document and you're going to have an end document, and everything that's between those is what is actually in your PDF. Okay, so currently we only have the make title. We have the section 1 called the introduction, and then we have the word hello, and that's it. So you can already see how we do section numbering. And the nice thing about sections is that they're actually numbered automatically. So I can have another section here like this, and it'll be numbered as section 2. And you can even have subsections. So like, for example, subsection, here's a subsection, and those will be numbered automatically as well. So that's subsection 2.1. Okay, so for the most part, if you want to just type regular text in your PDF, you can just type in the normal way. So, so text that you type in the document part of the source code, not the preamble. Anything that you type in there just appears as regular text in your PDF. A couple of things to note about it are that text will have the quote-unquote justified alignment. Now notice here I'm typing quote-unquote justified, and I've done it in a very weird way that does not look like what you're used to. You're used to using this double apostrophe thing, but double apostrophe thing does not look right in LaTeX. I'll show you what it looks like. Let me zoom in a little bit. So when you do double apostrophes, they come out always curled like this, like they're on the right side, which is not what you want. You want the one on the left to be curled like this one, and the one on the right to be curled like that. Okay, so in order to achieve that look, you have to do your quotes like they are over here in the source code. So you have those weird little backward apostrophe that's right above the tab key on the left, 2 of those, and then on the right is 2 single apostrophes. Okay, so anyway, as I was saying, text will have the justified alignment automatically, and also another thing that happens by default is that words will break over the end of the lines with hyphens. So let's see how that looks. I'm gonna get rid of this panel over here so we can zoom in a little bit. Okay, now when you want to do a new paragraph, you need to skip a line. Okay, so skip a line between each paragraph in order to have paragraphs correctly indented. So let me show you what happens if you don't skip a line. See there where I skipped a line? It didn't skip a line in the PDF. It just goes to the next line, but it indented it. And what happens if you don't skip a line in your source code? When you don't skip a line, it just stays in the same paragraph. Okay, let me show you. See, you thought you went to a new paragraph, but you didn't, because look over here, it's on the same paragraph as before, even though in the source code it was a new paragraph. Okay, and in fact, what's really going on here is that is that all white space is being eaten. So like, for example, if you put a whole bunch of spaces like this, space, 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 tab, 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 it's all going to be eaten. None of that is going to make it into the PDF. Okay. See, no white spaces over here, even though we had all this white space over here. That extra stuff will just be deleted. Okay. Now, one nice thing is that if you want to make something bold or italic, there's a really fast way to do it in Overleaf. Just highlight the part you want to be bold and hit Ctrl B, and it's going to automatically format it correctly with this little backslash text BF thingy. So that will come out as bold. There you go. And then italic works the same way. You can just highlight it, hit Ctrl I, and then that will be italic, just like this right here. Okay. Now, one thing I want to note here is that since this is a programming language, it is possible to do comments. Comments are things that you put in your source code that you do not want to be compiled. You want them to be ignored by the compiler. They're just there for the programmer to remind them of something. So like, for example, let's say I want to see how the PDF would look if this paragraph wasn't here, but I don't want to actually delete it. I can comment it out. So to comment something out, you just put a % in front of the sentences or the lines. And there's actually a keyboard shortcut for doing it automatically. So we do Ctrl Z, Ctrl Z, Ctrl Z, undo. If you highlight the part you want to comment out and do Ctrl/, it will comment out the whole section. So now when I compile this, that paragraph should be gone. Yep, it's gone. But if I want to get it back, I can highlight this again, hit Ctrl/ again. Whoop, it's back. Okay. So that is pretty darn useful. Okay, so now I want to talk about environments. So we've already seen one environment. An environment is sort of a conceptual concept. That's not a good phrase, a conceptual concept. It's a concept in LaTeX that has a kind of a big influence on how you go about typesetting things. So the environment that we've seen so far is actually the document environment. So when we had begin document and end document, that everything that is in between those is in the document environment. So an environment is text or commands that are between a begin and an end, and then the name of the environment is in those little curly braces. This one is document. And then some kind of special formatting or special set of commands is applied to the things that are in the environment. Okay, so I'm going to show you some other environments. So for example, if you want to center some text, notice here with the autocomplete, as soon as I typed \begin like that, it already pops up with like a whole bunch of environments that I could use. These are popular environments. So the one that I want to use is actually center. So I'm going to use the arrow key, down arrow key, to go down to center right there. And I'm just going to go ahead and hit tab to insert that. And you notice that Overleaf inserted both the begin and the end part. And it automatically also tabbed me over, which I don't really like being tabbed over in LaTeX. So I'm just going to get rid of the tab. So this is a centered piece of text. Putting it on a few lines there so you can see the centering effect. So looking at the PDF here, you see this is indeed centered right there. So you can center things in an environment. There's also an environment for doing bullet points, for example, the itemize environment. And then you have to use item in front of each thing that has a bullet point. This is item, a list of item, bullet, item, points. Let's see how that looks. Okay, so there's my bullet point environment. So there's tons of different environments, and one thing that you can do is you can actually define your own environment. And now is where I'm going to tell you what that mysterious command was that we did up here on line 3. That was actually defining a new environment. So what this command up there does is it makes a new environment that is basically a copy of the theorem environment. To be honest with you guys, I don't like fully understand why we always have to do this and it's not just built in, but this line is in literally every LaTeX document I've ever written. So it makes a new copy of the theorem environment, which apparently can't be used until you do this. And the particular command that we're going to use to call that environment or to put that environment into our document is the lowercase t theorem. The word that's going to be displayed on the page when we see text in that environment is this capital T theorem. And then the theorem is going to be numbered according to what section of the paper we're in. So that's what all that stuff means. So let me show you an example. So I'm going to come down here under my bullet point list and I'm going to do a theorem. So I'm going to do begin, theorem. Okay. And Overleaf went ahead and automatically put the end part in there for me. So this is a theorem. Let's see what it looks like. Okay, so here's my theorem. As you see, the word here that it's labeled with, that is coming from up here in my command. So I could have put anything there. I could have put Aletheia, my name, and then it would look like this. Now I have Aletheia 2.1. Oh no, a better version of myself. Oh, I don't want to compete. How could I win? But anyway, so change that back to theorem. And then the part here, this section, that is numbering the theorem according to the section that we're in. So we're in section 2 right here, and this is the first theorem, so it's theorem 2.1. And then if I put another theorem under that, I put another one. This is another theorem. That will be theorem 2.2. You see there? So they're numbered automatically, which is very nice. So theorem is a really important environment that we're going to see a lot of in this class. And the other really important environment that we're going to see a lot of is proof. So theorems should always be accompanied by either a proof or a reference to the place where you can find the proof. So I'm going to do begin, proof, and I'll show you what proof environment looks like. This is a proof. So the proof environment looks like this, starts with italic word proof, and it always has this little box after it. In the olden days, they used to put QED at the end of proofs, which was Latin. So olden days going back to the Middle Ages, I guess. But nowadays we just put a little box at the end of the proof like that. You sometimes see this in magazines too, like people put a box at the end of an article or even like a triangle or something like that. So we put those at the end of proofs. And the proof environment is going to insert that for you automatically, which is very nice. Okay, so that was all about typesetting, but we haven't done any math yet. So how do we typeset math? That's what LaTeX is for, right? That's the whole point of it. So when you want to type a mathematical expression, like a variable, all you have to do is you have to put it between dollar signs, okay? So as soon as you type $1, it will actually insert 2 of them for you. Overleaf does that automatically. And you're also gonna get this pink kind of highlighting error, which is because you didn't put anything in the dollar signs yet. So I'm gonna put an X in there. So you just use the dollar signs. Let me show you how it looks. So you see here that the X is italicized. It looks kind of fancy and like pretty. You can do more complicated ones too. Like for example, you could do like X plus Y equals 5 or something like that. And one thing that you're going to notice about this, this is called math mode. Things that are between the dollar signs are in math mode. One thing that I want you to notice is the following. In math mode, so I'm going to put this between dollar signs just to emphasize the point. Everything is italic and spaces get eaten. Okay, so it looks like there should be a bunch of spaces in there, but when we compile it, no spaces. There's no spaces at all. It all gets smooshed together like that. So that's actually by design. You want math to be that way. Like variables get smacked right up next to each other. There's not like spaces in equations. There are ways to like force spaces in there, but you don't really need to know about it. Okay, now this is the most basic way to get things into math mode, but this has a big limitation, and let me show you what it is. So, limitation of this method is that inline expressions get squished like this. Okay, so I'm going to do like a really big one. I'll show you how to do all this stuff later, but for now I'll just do it myself. Okay. So this is a really big expression I've just typed here. Look at it. There it is. All right. Do you see how squished that looks? This looks terrible because it's too big for the line it's on. Okay, so it got squished into that one line of text and it really looks bad. So when you're just talking about a single variable, for example, x like this over here, you can use the inline math mode of just single $sign, and just keep typing your line. So inline mode works great for discussing variables like, you know, a and b, and short expressions like a plus b equals c, but it doesn't work well for long expressions or tall expressions. Okay, so we need another way to get into math mode that is not in the middle of a line of text. So to typeset, and so to get into math mode without being in a line of text, use double $signs. Okay, so let me show you how that big fat math expression that I had before would look if I use double $signs. Okay, so I'm just going to put it on its own line, and instead of having $1 sign, I'm going to have $2 signs. And let me show you how it looks. Next page. Et voila, it's very beautiful. It's not squished anymore. It looks all fancy and pretty there on its own line. Everything has enough room to kind of breathe. Notice that it is also centered, which is typically how you would see an equation or an expression like that that's on its own line. It would be centered. Okay, so I just threw a bunch of complicated expressions together to do that I didn't explain any of them to you. So now let me explain how to write some of the sort of more common math things that you would want to write. So any mathematical symbol has an escape sequence. It's a kind of technical term from computer science. Another way we could say is just it has a command to write it. So some common examples are the following. So you never want to use the asterisk for multiplication. So asterisk is not for multiplication. Instead, we use \c dot. C dot. That stands for center dot. And that is the center of the line, like from top to bottom. You put a dot right in the center. That's for multiplication. So like, for example, if I want to do 5 times 7, I do 5 \c dot 7. And here I do actually have to put a space between, at least I think I do have to put a space between the c dot and the 7 so that LaTeX understands that the end of this command here is the t and not the 7. In other words, I could define an escape sequence that was c dot 7, and that's not what I want. Okay, some other common ones are the following. So some of these you'll memorize at some point, and others you'll just have to look up every time. There's C dots for putting 3 centered dots for like abbreviation for a long multiplication. There's dots, that's for doing ... at the bottom of the line. There is GEQ, that's for greater than or equal, LEQ, less than or equal, NEQ, not equal. INFT for infinity, IFF for double left-right arrow, IN for the set element symbol, subset EQ for subset or equal to, cup for union, cap for intersection, V for or, and wedge for and there's tons more. So any of these that you want to know, you can just Google them. So here's all the ones that just appeared. Those are my, oh, do C dots and dots do the same thing? Oh my gosh, I've been doing it wrong all these years. The more you know. Anyway, here's the greater than or equal, less than or equal, not equal, empty, if and only if, and all the other ones that I just was going over. Any others you want to know? Just Google it. All right, so that was symbols, and they're all in there. They exist for you to use. The next thing you might want to probably know how to do is exponents and subscripts. So for exponents, use the caret key. The caret key and the next character will go into the superscript. Superscript is like the typesetting word for an exponent. It's just like text that's at the top of the line. So for subscripts, use the underscore key. Now both of these are only going to the next character. They're only going to put the next character into the sub or superscript. So you need to wrap anything that's longer in curly braces to make it go into the subscript or superscript. Okay, so let me show you an example of what I mean. So for example, we could do x squared plus y sub 0 equals z to the, I don't know, 3, like this. So this should do what you think it will do. So 2 is in the superscript here, 0 is in the subscript here, and then 3 is in the superscript over here. Now what is meant by character is actually, for example, oh, I forgot to go over Greek letters. But for example, if I want to put pi up there in the superscript for z, I can do \pi, and that \pi, that's considered one character. So that will properly go up into the superscript without needing curly braces. Okay, but now if I want to put something longer up there, let me show you what happens. So let's say I want to do x to the 25, y sub 100, and z to the 2 pi. Let's see what that looks like if I just do it like that. Okay, it did not work correctly. So the 2 got into the superscript, but the 5 did not get up there. The 1 got into the subscript, but the 0, 0 did not. And the 2 got into the superscript, but pi did not get up there. Okay, so what you got to do is you got to wrap all that stuff in curly braces. Just think of it like, I don't know, saran wrap or something. I'm going to wrap my 25 here in these curly braces, and that's all going to go up there. Wrap the 100 in curly braces, wrap the 2 pi in curly braces. Okay, so now let's see how this looks. All right, yep, 25 went up there, 100 down there, 2 pi up there. Yeah, exactly like we wanted. Okay, so that is exponents and superscripts and subscripts. And since I forgot to go over Greek letters, let me do that for a second. So Greek letters, there aren't only Greek letters, there's like Hebrew letters and other alphabets too. But Greek letters are the ones we mostly use. So all you have to do is do backslash and then the name of the letter, like the letter spelling of it, A-L-P-H-A for alpha, for example, you know, beta, gamma, delta, and so on. So that will give you the lowercase ones. And then for the uppercase ones, you just capitalize it. So like capital A, alpha, not all caps, but just the first letter. Capital B, beta, capital G, gamma, capital D, delta, like that. Okay. Oh. All right, I forgot. This is a weird thing, but alpha, capital A, alpha, and capital B, beta don't exist because they just use regular capital A and B. Like it's the same as the English A and B. This has happened to me before that I forgot. I was like, why aren't they there? Okay. Yeah, it's just like regular A and B for those. All right. So next thing is some special constructions. So I showed you fractions a little bit just to make the point about why you put things on their own line. But there's a whole bunch of other things besides fractions that kind of like, I don't know, like move things around to different positions or shapes. So there's fractions, first of all. So fractions are like this. You do backslash frac, and then see it's got the little autocomplete there. I always just do the autocomplete. I just hit tab and put it in like that. So the first curly brace there is what goes on the top, and then the second one is bottom part. And you can actually use tab and shift tab to switch between these two curly brace thingies right here really quickly. It's a nice little feature of Overleaf. So that's fractions. When you want to do roots, you can do a square root with backslash sqrt and then put the curly braces. and then you put the contents in the curly braces like that. If you want to do a different root, like a cube root, it's actually the same command, but you just put a little square bracket with the root index right there, and then whatever you want. Oops, I forgot to put that in math mode. $. Oop, too many. Nope, $1. Yes, thank you. Okay. Okay, so there's fractions. Oh, I should have done these in double $signs. So there is fractions and roots. And there's a whole bunch of other things that are kind of similar to this. There's like summations, for example. Let's do one of those real quick. So you just do \sum underscore starting index and then superscript ending index. And then you can just put whatever you want to be in the summation after that, like this. So that makes the summation there. Looks really pretty. And there's a whole bunch more things like that, which you can Google if you want to know how to do them. One thing to keep in mind is named functions should not be italicized. The most famous ones are built in, like this. Let me show you what I mean. Like sign, for example, is a famous named function, but you don't do it like this. You don't do like sign of x like that. You put a \, in front, like that. And then it's gonna, LaTeX is gonna recognize that as the sign that it knows, and it's going to not italicize it, as it should not be italicized. I don't know if you guys have ever noticed that sign is not italicized in textbooks, nor is any named function. You know, like tan or arctan or whatever, that kind of stuff. And if you don't want the parentheses, you can just do this in, you know, curly braces, for example. Okay, so last thing I want to show you how to do is maybe a little bit, I don't know, this might be too advanced, but it's pretty useful, so I'm going to show it to you anyway. So parentheses, we haven't really done them yet. Parentheses are not sized automatically. So let me show you what I mean. Let's do a fraction with parentheses around it. So I'm going to do frac 1 over, let's do 1 over 2. And I put parentheses around it. Let's see what that looks like. Okay, you guys can see it does not look good. That is not the right size of parentheses, right? But there is a way to size them automatically. So you can size parentheses automatically with \left and \right. And I'm getting errors on those. So let me put them in math mode. \right. So basically you put the \left right before the left parenthesis, just like this. And then you put the \right in front of the right parenthesis. So let me copy the fraction that I just did and do it with left and right there. So in front of the first parenthesis, \left, in front of the second parenthesis, \right, compile. And you see there we have the correctly sized parentheses. And this is really nice because you can keep putting like more and more of them together and it'll just keep auto sizing them correctly. So for example, if I could put the same thing, I'll paste it in here for where the 2 is, or 2 plus that. See, now I've got like multiple sizes of parentheses, but they're still all, you know, sized nicely. So that's pretty great. So last thing I want to tell you is that there is so much more stuff that you can do with LaTeX than this. So I just want to show you a couple of more things that exist, although I'm not going to show you how to do them. I'll just show you that they exist. And I'm going to use my own paper that was published last year to demonstrate. So let's look at this paper together. First of all, a few more things that you can do just to kind of get you excited about LaTeX is you can actually draw pictures and diagrams in LaTeX. So this picture right here, this is not like a JPEG or a GIF or anything. That is drawn with code. Okay, so this code right over here draws this picture over here. And same with this one on the right. So that's pretty cool. As I said, it's not just mathematicians that use LaTeX, it's also computer scientists. So this is actually a computer science paper that I wrote, basically, kind of like border of math and computer science. So you can typeset your algorithms like this one, formal typesetting of code like this. And another thing that you can do is you can actually do hyperlinks within your paper. So for example, these are references to my bibliography, and if I click on them, it jumps me right down to where the reference was in the bibliography. And the bibliography itself is another really nice thing that you can do in LaTeX. If you look at where the code is for my bibliography, the code for my bibliography is those 2 lines, which tell LaTeX to make the bibliography itself, and it does. It makes it in the right format. It inserts everything automatically for me from another source file, which is over here. And then it puts in all those hyperlinks and stuff automatically. It's really nice. And then the last thing is you can put in pictures like JPEGs, GIFs, PNGs, and so on. So this is a picture that's over here. It's one of these files. So you can do all kinds of fancy stuff like that in LaTeX. And yeah, if you have any questions about how to do anything in LaTeX, my sincere advice would be to seriously just Google it. So let me give you a little example. Like, let's say you want to use a red text in LaTeX. So I would Google, how do I make text red in LaTeX? And you're probably going to get a link from either Overleaf itself or you're going to get a link from Stack Exchange. You guys know about Stack Exchange? You haven't been Googling enough if you don't know. So you're just going to read whatever it is and just copy whatever they did. I learned every single thing that I know about LaTeX from Stack Exchange. So if I learned it there, then you can learn it too. People will ask questions on here and then other people will answer them and tell them how to do it. So here they're telling you need to use this package, and then once you have the package, then you can use this, environment here. All right, but if you have some problems and you can't figure them out by Googling, of course, feel free to send me a message through Teams. You can post to the general channel in Teams if you want anyone to be able to answer, or you can ask me a question directly, I guess, if you're embarrassed. And I'll be happy to help you out. All right, thanks for watching.